So before the break, we're going to have the one component which stitches all this together, and that's literally the kind of the cord orchestrator, cord controller, whatever you want to call it, and it's XOS.
Thanks. So yeah, interestingly, this has not been a standalone component. It's been the behind-the-scenes thing that has to happen to pull all these parts you've been hearing about together. But what we're going to do is carve it off as its own component. You can use it or you can use something else. And what I wanted to do is try to capture what it is exactly that it's doing, all right? And I wanted to start by trying to approach this problem in a chord-independent way. We think this is a general problem. We have some experience with this problem in chord, and so that's clearly going to inform how we go about addressing it. But the problem very generally is it's a logically centralized model-based service for operating microservice-based cloud applications. We're building a lot of cloud applications based on microservices. There's some great tools out there. Kubernetes is an example that we're leveraging. Kubernetes does a whole lot of stuff for you. It allows you to incrementally roll out images, scale them up, scale them down, recover from failure. There's a lot of great things that it does, but there's a little extra something that it doesn't do. And that is what we are focusing on here, and that's configuring and controlling the stuff running inside of those containers, except do it on an application-wide basis. So you're trying to build an application, but you're building it from a bunch of parts. How do you operate that thing on an application-wide basis? And so that's the general problem, and I think there's a way of explaining that starts with the Kubernetes and shows you a value add beyond that. But what I'm going to do instead is talk about it specifically in the context of chord. So in that context, you've seen pictures like this since the beginning of chord, and it's a very functional view of chord. It's a very abstract view that says chord's built from a set of services. That's great. It is, in fact, XOS that understands services. So instead of functional view, I could have called that the model view. It's the intent. This is what I want. But what you really have under the covers is a bunch of code running. And so from a component view, we know that we have a set of containers and or VMs that we want to scale up and down, and we call those VNFs. We also know that, and those get then loaded onto the processors in our chord cluster. We also know that we have a set of ONOS applications or SDN applications. It wouldn't have to be ONOS, but there's a set of control apps that run on something like ONOS, and that's controlling the switching fabric. And so if you look at these different kinds of implementations, let me just start at the bottom. What we really have is a service data plane, kind of an analog of a network data plane, that's built in many different ways. It can be built from VMs, containers. It can be built from server-based functions. It can be built from switch-based functions. We know it's going to be highly disaggregated, so it's borrowing the philosophy of microservices. We're going to break these into as smallest parts as we possibly can. That's a very diverse collection of things that we need to manage. And so what the chord controller does, and XOS is the implementation of the chord controller, is it layers a service plane, a control plane, but now we're talking about a service control plane, not a network control plane, on top of the service data plane. And that's the place that you then provision those boxes running below, and you control them as they're running. And it actually can play a role in assembling all the little bits and pieces together to give you the end-to-end data path that packets flow over. So this notion of separating the control and data plane is really an essential one, but I wanted to try to get to one other view, and that's an operational view. And that is, once you've got this thing up and running, there's actually multiple players that want to interact with it directly or indirectly. So on the one hand, we actually have a way of controlling on a per subscriber basis this chord box. And subscribers could look at what service they're getting. You could actually build a self-service portal if you wanted to. Now, maybe an operator would really want to indirect through some other database that has credit cards associated with it and billing addresses. That's an implementation choice. But from the point of view of this box, there's visibility at the granularity of individual subscribers and how their data paths are working, how they're assembled. And those data paths can be wireline or wireless. And of course, and then chord/XOS plays a role in actually assembling the service chains from that. And of course, there's still the operator, and the operator has some configuration and provisioning operations that they want to bring to that box as well, and they're getting telemetry data back so they know how to react, and maybe there's not a human sitting there, but it's actually analytics programs or whatnot, but that's the general idea. But the point is, there's two different granularities that you work at. You work at the operator is the stakeholder. These are the resources I'm going to throw at these problems. And there's the users of the cloud, And if you kind of just momentarily think of this as a cloud, then we're literally talking about the tenants of a cloud. And they want to get service from that cloud, and they want to have an interface as well. Well, so stepping back from that, and there's a lot of, I apologize, there's too many words in this slide. We're still trying to hone the message here, but I put in bold the three key ideas. The first key idea is to unify. And so this is the boring piece. This is just to say there's a little bit of middleware that's managing some state, and it's doing it in a consistent way because all of those back-end pieces may have done it differently. And so if you're going to build something northbound of this, and we're actually in the middle of integrating Volta/R cord into different operator environments, and there's different northbound, and we don't have to have, we want to avoid the situation where they have to deal with each of the individual components underneath. It's just a piece of middleware that unifies that. And it does it across all of those components in a consistent way. So that's kind of the low-hanging fruit of value that you get. The second thing that you get is it's declarative. So there's actually a programming language for coming in and saying, I want this to be something that I can control. I don't care if it's implemented by ONF, I don't care if it's implemented by Kubernetes, I don't care if it's implemented by OpenStack, I don't care if it's implemented as a combination of those. That's a unit I want controlled, and I can declare models that will do that across logical services, distributed service, compound services, and so on. So it's a programming language for doing that. The third thing that is that it's fine-grained. So this gets back to those stakeholders. There's actually a way, because what I'm doing here is carrying user traffic from an access network onto the backbone and vice versa, that at that granularity, I want to be able to have visibility, I want to be able to control, and possibly I want to be able to move over time as this becomes more mobile. And I want to allocate resources because these different customers are willing to pay different amounts of money. So the fine-grained aspect of this, it's not just slop down a VM, it's actually fine-grained control whatever implementation was there on behalf of subscribers or classes of subscribers. So what is it? It's not as much as you think it is. XOS is actually just 25,000, 30,000 lines of code. It's a declarative language, which is a variant of protobufs. Syntactically, it could be protobufs. It could have been a different syntax. We could build its own software project. We may choose to implement some other syntaxes, but today it's protobufs. But it's been extended to support some things that we needed. It's a generative tool chain. We generate code so that whatever was declared is enforced by the underlying systems, and it's extensible. So if you want to build new targets, it's very easy to add new targets to this generative tool chain. Wherever you think you need a bit of code to enforce the models, you write a new target. It has a default set of models defined, and this is expressed in xproto, but it's the core.xproto. That's the default set of core models that we have found useful for Cord up to this point, but it's entirely malleable. The whole point is that if you have an insight that will allow you to better operate your network, or you have a new feature or capability like mobility to bring to your network, you just go into those xproto files and you define the models accordingly. So it's entirely a programmable environment. And finally, it's a deployment. It's a way to deploy, and what we're doing now in the latest version of Cord, which is certainly what's already been happening with XOS, is we'll give you a Helm chart that says go off and deploy Cord. And now you have it, and it can manage whatever back-end systems you want it to manage. So in that sense, it's a completely self-contained thing. And if you want to deploy something other than XOS, then that's the point at which you would deploy something other than XOS. But it's itself made up of a set of microservices. So I just wanted those four things. I just got one slide on each real quickly just to get a picture in your head. So it's a set of microservices. There's a data model. There's a cord. The data model's persistent. There's an event bus. You can implement a set of targets on top of it that are APIs that northbound orchestrators or whatever can talk to. And there's southbound, there's a little bit of glue code that you have to provide. We call them synchronizers to manage the back-end systems based upon the data model. This is just an example of what the xproto looks like. This is the definition of a model called privilege. And if you know protobufs, it looks just like protobufs. There's also, though, the ability to define predicates that say, evaluate to true or false, and then you take some action based upon that. So it's a way to impose invariance on the models to make them conform with the behavior that you wanted out of the back-end system. It's a generative tool chain. And so one of the things that happens is that when you provide the set of models to the system, it goes off and generates a whole bunch of code to make sure those models are enforced. So you can generate APIs, you can generate test cases for the APIs, you can generate security enforcement, you can generate object management databases, object relation mappers, you can generate the code for the synchronizers. And that's, again, an extensible set of things that you can generate, but it's the point at which you have the opportunity to enforce the models on the rest of the system. And then finally, it's a set of core models. And there's no magic with these models. They're just the ones that we've come to understand over the last 5 years of trying to get systems like Cord up and running. So there's a model for a service. It has two subcomponents. One is the control component, of which you get service instances, but that's just the way I manage the service. Then there's the actual implementation of the service in a set of resources. But we sometimes confuse the instances that might be a container instance with the service instance, which is a purely logical abstract thing. And by the way, that just happens to be what the picture looks like when the service is implemented in a set of containers. It might have been implemented as an ONOS app. And so again, there's service instances. Those are the logical controllers of the service. And then there might be some particular service like vRouter that we're trying to control. And then once I get the definition of models, I can string models together, and I can create aggregates of models. And in fact, RCord, we didn't understand this at first, but RCord is just yet another service, but it's a service built from other services that we'd already disaggregated. And each one of those services can have a set of instances. Those instances get linked together. And so now we have both the service graph, which is a fairly static thing that the operator would specify. And every time somebody turns on their home router, in the case of RCord, and they connect to the internet through Cord or through the XOS controller, then you get a service chain on behalf of that particular subscriber, or it could have been a class of subscribers that I wanted to give a similar set of resource behavior to. And just kind of to elaborate a little bit, once you can define these models, one of the things that we've done is just another example of a composite service, a service built out of other services. We have EPC as a service built from the components virtualized MME, a virtualized PS gateway, and so on. So this is now a composite service built out of services. It's a purely logical thing. It doesn't exist anywhere in the underlying implementation. It's purely logical. And now that I've got this purely logical thing, I can multiply instantiate it, and I can give different resources to different one of these, and that's how we implement network slicing, or how we control network slicing. So I think I will stop there, see if there's any questions, and maybe get us back on schedule a little bit.
Questions?
Hi, Guy Metter from Cox Communications. How does the XOS participate in the integration with ONAP that was described earlier?
Yeah, so everyone wants to know the answer to that. So it's purely acting locally. It has no global, it's not doing anything global. And it exports a northbound interface through which you then control all of Cord. And that interface, well, actually just any one of those. So I said Vim, well, actually Vim. That might have been the interface by which ONAP interacted with it. Now, ONAP doesn't necessarily have the same understanding of the disaggregated microservices that are implemented in Cord. So one way to think about this is, actually just to go back to this picture, ONAP might have said to Cord, please instantiate our Cord, which caused a set of services to be instantiated. And then it might have said, I need an instance of our Cord, which would have caused you to have an instance of each one of the subservices. So the granularity might not be one-to-one. Over time, it might turn out that way, but initially it may not be.
This is Dustin of QCT. So along the same line, so as you just described, actually these two are not necessarily contradictory to each other. So do you think they play complementary role to each other? For example, there is another initiative going on right now called OSAM, right?
Yep.
OSAM. What kind of role is that project playing in this transition?
Yeah, as of right now, OSAM, which is Open Source Access Manager, is another use case of what we're doing with Cord/XOS. So So from the point of view of managing an access device, which it just happens to internally be built out of commodity components and white boxes and open source software, Awesome is a way of interfacing with that. And so the Awesome XOS team are working very closely to try to do that.
Anyone else? All right.